This is day one, a new home on a gently sloped section, and the first step is to use the measurements on the setout plan to work out exactly where the house sits. My first two corners are located using the parallel line from the boundary and a diagonal line from the property corner. This is where the memories of Year 10 maths and the early years of my career return and remind me of how far we've come. I used to use Pythagoras on calculators to work out the diagonal distance of a square or rectangle layout. Now I just use an app on my phone. I swing a tape measure from each peg along the wall length and the diagonal distance, and where these intersect is my next corner. There is a hidden trap here. I need to adjust my measurements for the slope. Due to basic geometry, those measurements actually need to be longer. If you're familiar with Pythagoras, you'll know that the right angle triangle has a longer side, the hypotenuse. On a sloping site, that longer side is the ground itself, while the dimensions on the plan only show the flat horizontal distances. To work this out, I essentially flip the triangle upside down and use Pythagoras again to calculate my sloping dimensions. The contour lines show at least a 2.5 meter drop in height from the back of the house to the front, which means a 16 meter horizontal distance will become a 16.2 meter distance on the slope. At this stage, it's also important to check the accuracy of the existing heights at each corner. What these checks revealed is that if I followed the designer's intention, setting the house height 550 millimeters from the current ground level at the back corner, I'd end up with piles exceeding 3 meters at the front. That goes beyond the scope of the plans and NZS 3604, the New Zealand standard for timber frame buildings. It would require specific engineering design and significantly impact the height and number of stairs needed to access the home. After discussing it with the relevant parties, my solution to excavate and cut the back corner into the slope was accepted, and the FFL, finished floor level, was adjusted to suit. Now that I've located where the house sits, I need to build profiles to carry my string lines. A basic profile is a temporary frame built with some stakes in the ground and a horizontal rail known as a batter board. They are built outside of the corners of a building, and the string lines that represent the building outline are tied to them. It also helps if they are built to floor level. These lower ones give you an indication of how much the back corner needs to be excavated. As I get higher out of the ground, my profiles need braces to stay rigid, and for the right angle braces to work effectively, they need to be no more than 45 degrees. The easy way to work this out is to measure the height above ground that the brace will attach to the upright, and that is how far out the brace needs to attach to the ground, also known as a 1-to-1. I've built two sets of profiles here, the corner and a single one further back. The short profile captures the line of the front of the house, and the corner profile captures the front of the deck and the side of the house. The last profile I need to build is the tallest, and it also captures more than one corner. Pre-attaching the braces to the uprights helps when getting started, and then I work my way up from there. I also use a mid-rail on this profile to keep the uprights rigid so they don't bow and buckle. Good access is important, especially when the batterboard is 3 metres off the ground. I prefer the practicality and stability of a scaffold here, and the ease of setup that my quick stage scaffold set provides. That completes the first part of the house setup. I've established the corners and I've built my profiles. If you want to see how I build this 76 square metre house on timber subfloor with redwood weatherboard cladding and more, then keep an eye out for episode 2 where I set up the string lines and get the excavations and pile hole drilling underway. Thanks for watching.